Hello friends, in this video we'll be taking a look at the autosomal DNA results, predicted phenotype traits, and even GD match results of a Viking age inhabitant of northern Russia. This individual is from this location right by the lake Ladoga. This is the route that Vikings, and this is what we call them varyags in Russian. This is the route that they would take to trade with the Greeks down south. They would go to the lake Ladoga. They would take these rivers to Ilmen Lake, and then they would take Dnieper to the Black Sea, and that's how they would trade with these people down south. So they would pass through Russia and Ukraine. Sometimes they would take the Volga route as well and trade with the Persians. There was actually some trade between the Vikings and the Persians. People might not know that, but yes, they would take the Volga route down to the Caspian Sea, and they would trade with Persians. Now, this individual is, based on his ethnicity, most likely not Russian. Most likely, this individual is not Slavic. He is a mixture of Germanic, so Viking, plus a little bit of native Finno-Ugric people that live there. So he's basically like a mixture of Vepsian or Chudes or whoever lived in this region, whatever Finno-Ugric ethnicity lived in this region, with Germanic, with Viking. And this is probably a representative genetic profile of what those Vikings who traded with the Greeks and the Persians most likely looked like and most likely resembled ethnically. So let's go ahead and explore his Y-DNA. His Y-DNA is actually very exotic, really exotic Y-DNA. His Y-DNA is T. My trait predictor actually does not look for T. The closest my trait predictor looks for to T is L, and he does not have any L variants. It He does have. Wait, let me see. He does have the F haplogroup. His Y-DNA is F, which is true indeed because T does descend from F. It's F to K to T. In terms of K, I'm a little bit disappointed here. For K, it looks like 0 out of 0 was found. That's because this file is simply not very high quality. So, in regards to K haplogroup, um, there is not enough data to really classify him this way, unfortunately. So, we can't really, just looking at my trait predictor, you wouldn't really be able to know that he has T haplogroup, but indeed his haplogroup, his Y-DNA is indeed T. When it comes to ethnicity and ethnic calculator results, we're going to start with this. So with my ethnic calculator, with Trait Predictor's ethnic calculator, he is closest to Livonians from Estonia, followed by Turkic from Caspian Steppe. This one Turkic individual, very interesting. Followed by this individual, Corridor individual from Lithuania. So he's clearly, based on this oracle, he's clearly quite Eastern shifted, quite East Asian, East Eurasian shifted, right? And he's actually getting modeled as a mixture of global or Amphora plus Turkic or Corridor plus Turkic. Um, Basically, there's a very clear East Eurasian admixture here. And let's see, does GED match agree with this? All right, so with GED match, GED match actually does not agree with this. With GED match, he's scoring only 3% Siberian. There really isn't all that much East Eurasian admixture. He's actually got less Siberian and East Eurasian admixture than I do, and I don't have any known Finno-Ugric ancestry. How do we know this individual has Finno-Ugric ancestry, though? We know this because he does not score much Mediterranean components. He doesn't score much West Med. He does not score much West Asian. He doesn't score any West Asian, and he does not score much East Mediterranean. So, all this considered, this lack of Mediterranean admixture, this lack of Southern admixture, is how we know that this individual is of Finno-Ugric stock. Because, like Slavic Russians, for example, Slavic Russians score 2 times more West Mediterranean and a lot of West Asian, like 5 to 7% typically. So this individual is clearly not a Slavic Russian. How do we know that this individual has Germanic admixture? Well, we know that he has Germanic admixture because he's scoring 43.5% North Atlantic. Once again, this is not typical for Finnish people or Estonians or Chuds or Livonians or whatever. It's not typical for these Northeast European Finno-Ugric people to score 43% North Atlantic. In fact, more North Atlantic than Baltic. Clearly, this individual has a lot of Northwest European genetic drift. So there is some Northwest European admixture present here. Let's go ahead and check the oracle and see what the oracle is going to model him as. So the oracle is saying he's closest to Southwest Finns and North Swedes. If you remember, the previous individual from Ladoga I made a video on was scoring pretty much the same thing. So this individual and the previous Viking Age individual from Ladoga, They both kind of have the same genetic profile. I could probably say right now that this is a typical, ethnicity wise, it's a typical profile for um, a Viking, a Viking inhabitant of Russia, of northwestern Russia. And with the Oracle, he's getting modeled as a mixture of Southwest Finnish plus North Swedish. So both of these populations are a mixture of Germanic and Finno-Ugric. Both Southwest Finns and North Swedes are a mixture of Germanic and Finno-Ugric. There's also Southwest Finnish plus Norwegian. There is Southwest Finnish plus Swedish. Very interesting. There's Finnish plus Danish. So yeah, a little bit more Finno-Ugric than Germanic. It looks like uh, a little bit more Finno-Ugric than Germanic. Yeah, but um, there is Germanic admixture here. It's very apparent. All right, now let's go ahead and explore what he looked like, his phenotype, his traits. We're gonna start with noshacot, and it looks like he's got a blue eyes with an amber center or hazel eyes. Actually, a little bit darker in terms of eye color than the previous sample I made videos on. Although the spread here is pretty large, so when you see a spread that's this large, there probably isn't a lot of data in the file. We're gonna check it later. And for hair color, he's scoring light brown hair or dark brown or dark blonde hair. So it looks like for hair color, or there's actually a pretty significant likelihood of red hair as well, which is kind of interesting. So it looks like for hair color, his hair color is most likely in the brown range, probably lighter brown. And for skin color, he's scoring white skin, definitely not light brown or dark brown skin. Probably not olive either, but palest skin is pretty possible here as well. For hair texture, it looks like he's got wavy hair, but once again, the spread is pretty large. Okay, yeah, okay. So this is the problem, right? We scroll back to this and we see things like that. Obviously, um, when so much of the important data is missing from the file, you cannot get a very precise prediction. This is why it's kind of all over the place. 10% blue eyes, 12% brown eyes. It's really all over the place, isn't it? And that's because most of the really important relevant stuff is not found in the file. So what we're going to talk about the stuff that is found in the file that did contribute to the result, and it's that he has blue eye haplotype 1. This is also predictive of blue eye haplotype 1, so he definitely has blue eye haplotype 1. He has some other light color variants. This is Oka2, by the way, not Herc2. He has this variation, these two variants in SLC 24A5. So he's got light skin. This is mainly has to do with skin color. He's got light skin here as well on Asip. It looks like he's got a light pigmentation variants in SLC 45A2 as well. So all around, it looks like there's two light variants in both of the skin color variants for Keto G. So it looks like he has light skin for sure. I'm not sure actually why it predicted him to have such a high score for hazel eyes. Let's find out. Let's find out why. Okay, so it may have something to do with him scoring zero light color variants in this variation of tier 1 and zero light color variants in these variations of tier that contributed. Zero light color variants in these variations of IRF4 also contributed for sure. This contributed as well, and I don't really remember the contribution that this has and this has, but it does have a contribution. It does play a role in result as well. So it looks like altogether there is actually some dark pigmentation variants this individual has as well that contributed to him scoring what is it, hazel eyes rather than like blue eyes. And of course, if this individual has blue eye haplotype 2 and blue eye haplotype 3, this would change the score like entirely. If there was a genotype and he had, like, for example, TT here or GG here, the score would be completely different, right? Because these are by far the most important variations, and they are simply absent. The genotypes for this are absent from the file, which is a big bummer. So even though my tool does imputation when there is nothing to impute from, there is there's going to be some issues. And for MC1R, he actually has two derived variants here, so it looks like he does have ginger variants in MC1R, and this is a big reason for him scoring such a high score for red hair. It's because he's got some ginger variants in MC1R. All right, let's go ahead and explore his polygenic risk scores. So for the polygenic risk scores, it looks like he's got a below average score for schizophrenia, below average score for type 2 diabetes, a average score for Alzheimer's, He's got a below average score for multiple sclerosis. So far, really good. For cancer section, 3 for breast cancer out of 14, really good to see. 9 risk variants for testicular cancer out of 10. This is not good to see at all. This is really alarming. Okay, we're gonna watch out for testicular cancer here. 0 risk variance for celiac disease out of 2. Well, unfortunately, not a lot of stuff was found in the file. As you might have noticed, it's not a particularly high quality file. 0 risk variance for GSS out of 8. Once again, not much to go off here. 1 risk variant for Crohn's out of 18, pretty typical. 0 for Riefenstein's out of 2, pretty typical. 5 out of for Parkinson's out of 18, really alarming, but we can't really check where those variants are from. Okay. It looks like this individual has got the Warrior genotype in MAOA, so definitely higher number of dopamine activity in the brain, I guess. So it is slower dopamine reuptake, less MAOA enzyme, and slower dopamine reuptake, therefore higher dopamine levels. That's what I was trying to say. And advantages in attention and memory tasks, really good to see. Disadvantages in stress resiliency. These are the implications that go together with being a warrior. This individual also has two derived no-go learner variants, DRD2 provenance in pro variation. It is extremely European, actually. Both these genotypes are extremely stereotypically European. So it looks like he's got a reduction in the number of dopamine D2 receptor sites in the brain, a reduction in the risk of schizophrenia, and an increased likelihood of being a no-go learner. Um, it looks like he does not have the A1 allele TAC1. So, okay, in TAC1, it looks like he's got a little bit more dopamine D2 receptor sites in the brain. This is like the reverse in terms of the effect it has on the I guess the phenotype. Has the reverse effect as this genotype. So this genotype would reduce the number of dopamine D2 receptors in the brain slightly, and this genotype would increase that number slightly relative to the average. Most people have GG here, so most people have a slightly increased number of dopamine D2 receptor sites in the brain if you only take into account TAC1. It really, what you should really interpret this is you should interpret it as an absence of the A allele, and the A allele is something that greatly reduces the number of dopamine D2 receptor sites in the brain. It looks like this individual does not have long form 5-HTTL-PR and also does not have a decrease in the risk of depression, so pretty typical risk for depression, slightly higher risk for depression than average. All right, now we are going to skip the autism. I don't care about that. We're going to skip the DDC gene panel. For lactose persistence, it looks like he has one derived variant for European lactose persistence and is likely not lactose intolerant. This is not the main variation that most services look for, but it is linked to the main variation, which is this one. So it looks like he does not carry the European lactose persistence variants in the main variation of MCM6, but he does carry them in the secondary variation of MCM6. I'm not sure which one is well, obviously, the main one is probably the more important one in terms of its effect, but I did find studies that suggest that this variation also has a significant impact on the phenotype, which is why I included it here. For OXTR and the empathy gene, this is just a really poor file. Like most of this stuff is simply not found in the file here. But it looks like he does not have um, the the increased empathy gene. It looks like he's got lower levels of empathy based on his genotype here in OXTR. So maybe a little bit of a sociopathic tendency. For diabetes, it looks like he does not have type 1 diabetes. Really good to see. For hemochromatosis, he is not a carrier for the C282Y hemochromatosis mutation. Does not have hemochromatosis. For Alzheimer's, it looks like he has got this genotype, which leads to a decreased risk of Alzheimer's, but together with this genotype, which actually leads to a slightly increased risk of Alzheimer's. Very interesting to see. For multiple sclerosis, it looks like he does not have any risk variants for MS. Um, in this variation, it's not that big of a deal because the risk variants are really common. For cardiovascular disease, should I really bother with this? Because it's just so like uninteresting in my opinion. Okay, so for miscellaneous section, we're gonna move on to this. It looks like this individual does not have micropenis. Really good to see. Unfortunately, with most of these samples, especially with 1240K samples, which this is not one of those. This is not a 1240K sample, but with 1240K samples, I noticed that micropenis seems to be very, very common, and obviously, it's really rare. It's a really rare mutation in the real world. So obviously, the problem is with the files. The problem is with the genotyping, or some kind of, or the method of conversion that I use. So it's obviously not a genuine genotype in most cases where you see micropenis in my videos. In most cases, it's not the actual genotype of the sample. It's probably some kind of genotyping error. But in this case, this individual does not have micropenis. Really good to see. 8 points lower IQ than individuals with GG genotype. Very interesting genotype here. It looks like this individual is a mix of muscle types, likely more sprinter than endurance athlete. And for EDAR, he's got very European genotype in EDAR, no East Asian EDAR. He's also not an Asian flusher, and he has lower odds of alcoholism. You know, there is this stereotype that people from Northeast Europe, especially like Russians, Finnish people, Poles, Ukrainians, people from northeastern portion of Europe, there's this stereotype that we are like predisposed to alcoholism. I'm not sure if it's like biologically backed. I'm not sure if from a biological point of view it's true, but there is this stereotype. So this individual has got lower odds of alcoholism, and he is not an Asian flusher. All right, so he doesn't flush up when he drinks, like vodka or something. For drug response, he's got lower odds of cannabis-induced psychosis. The T allele here, the derived allele, peaks in Spanish people and It peaks in Europeans, but out of all Europeans, it actually peaks in Spanish people. Very interesting to see. I wonder why it is that Europeans have this allele that protects us from cannabis-induced psychosis. Maybe it's because historically we've been smoking cannabis a lot recreationally. I'm not sure. I don't really know. Um, for albinism, it looks like this individual does not carry any of the albino variants. Does has this genotype, which leads to a decreased risk of cleft lip and palate. Really good to see, and he's also not a carrier of Melanesian blonde hair variants. For familiar Mediterranean fever, it looks like this individual does not have any risk variants for that. For MTHFR panel, he's got this genotype, which is pretty much normal, good, no problems metabolizing folic acid, and it looks like he's got lower odds for a variety of illnesses from autism to coronary heart disease here. Very good to see. So for cancers, we remember that he was scoring a crazy score for testicular cancer. So it looks like he's got new genotypes which lead to a significantly higher risk of testicular cancer. And I think in a full file, in a file that contains all information that my trait predictor looks for, you will see on the screen showing up um, three lines for testicular cancer. So here we see two lines, but really it should be three. So it looks like for testicular cancer, when it comes to the important variations, and those three are the most important variations, they're actually in keto G gene. For the most important variations for testicular cancer, we're actually getting pretty good coverage, which is kind of scary because this individual scored 9 out of 10 risk variants, where typically you're supposed to score like around one half. So yeah, really unusual stuff. For leukemia, there's this genotype which leads to a increased risk of leukemia, which is very interesting. And he's not a carrier for variants for Bloom syndrome, no GSS, and he's got this genotype, which is actually really uncommon. And this really uncommon genotype leads to a significant decrease in the risk of certain autoimmune diseases such as type 1 diabetes or Addison's. So probably does not have type 1 diabetes. Once again, really good to see. For celiac disease panel, does not have risk variants in HLA. So it looks like. And by the way, HLA, it's like it's a big region that's located right next to each other. It's a bunch of little variations that are located right next to each other, and my trait predictor looks for all of them. But really, if you have the genotype for one, you don't really need the genotype for all the other ones because they are linked, they are inherited together, and they are linked. They form a haplotype. So we can assume that this individual really doesn't have any risk variants for celiac disease. Really good to see. Androgen receptor gene panel, it looks like he has got typical or slightly higher odds of baldness, so he does not have the allele that protects from going bald. For Crohn's disease, it looks like he has normal or lower risk of Crohn's. Really good to see once again. For Canavan syndrome, zero risk variants. For HIV and AIDS panel, it looks like he does not have any risk variants for. Well, you know what HIV and AIDS panel, what it really is about? It's about viral load, right? It's about how quickly the virus turns from HIV into like actually compromising your immune system and leading to you developing AIDS, right? So having risk variants here really means that your viral load is higher, and it means that the speed at which it turns into AIDS is going to be a little bit quicker. So in this case, it's good that he does not have any risk variants. It means that he's a little bit resistant to HIV turning into AIDS, which is really good to see. I think it's a very European trait as well. Europeans are a little bit protected from HIV compared to other ethnicities. For muscular dystrophy, it looks like zero risk evidence here, and zero risk evidence for adrenoleukodystrophy out of 10 total. Once again, really good to see. Unfortunately, it's not a very high quality file, so there's not much information here. Well, thanks for watching the video until the end. Leave a like and subscribe if you enjoyed it. You can download this file in 23andMe format from link which is in the description of the video. Thanks for watching. Goodbye.